Hello everyone and welcome to the part 2 of the Making a Programming Language series. So let's start. I don't know why I have those on, but I'm not gonna have those on. So I'm standing here in the Hello project that we made in the previous video. If you haven't watched the previous video or the first part of this series, I'll put the link in the description. So what we did last time was basically focusing on the make file, right? So that we could compile our project. So we were focusing on this so that you could do this, compile it and run it. And you can also do sudo make install. And it will install it globally on your system. So today we're going to do some programming actually. We're going to start with the first part in the, what do you say? We're going to do the first part of a programming language today, which is the lexing part. So we're going to turn some source code into tokens basically. We're not going to be able to run our programming language today, but we'll be able to run the Lexer, I guess. Let me bring up GIMP here real quick. I'm gonna draw a little bit for you before we start, so that you, so that everyone understands what we're doing here. So let's just let's put this on full screen. I think my face will disappear for a little bit here now, but we'll have to deal with that. Let's do 640 by 480. Okay, so basically we're gonna have three parts in our programming language. The first part is going to be, actually let's bring this to another workspace like that, and then we can work here. And let's put my webcam float, and there we go. So the first part is going to be the, oh, that's a very small brush. The first part is going to be the Lexer. And then once we have written the Lexer, we're going to write the parser. So what is a parser then? The parser takes the tokens from the Lexer and creates an abstract syntax tree. And the short for that is AST. And then we're gonna write a visitor basically, or yeah, I guess you can call it a visitor. Visitor, and the visitor is just going to visit every node in the tree and perform operations based on what's in the tree. Now, if you want to make a compiled language, the only part here that you would switch out is this one. So even if you're making an interpreted language or a compiled language, you're still going to want these parts. And today we are going to focus on this part. So let's start with that. So let's have some fun. So we're going to go into the editor and we're going to create another file inside of the include folder. And we're going to call this lexer.h. So now we're going to define our Lexer here. Let's do if not defined lexer age, define lexer age and diff. And we're going to have a struct that we're going to use a struct to store the current state of the Lexer basically. So type def struct lexer struct, lexer t, and we're gonna have the current character that we're on, and we're gonna have an unsigned int index, or let's just call it I. So, and we're also going to have some contents, and the contents is the source code that we're gonna parse, basically, or lex. Okay, and then the lexer is going to have a couple methods. The first one obviously is going to be the init lexer function, which creates our lexer, and it's going to take in some contents from a file or wherever it's from. Then we're gonna have a function called lexer advance, and we're gonna pass in the lexer state into this one. And the lexer advance is basically just going to move our pointer to the next character in the content, basically. If it's possible. If we're at the last character, it's not going to do that. Then we're going to have another method called lexer skip white space, because we're going to skip white space that we don't care about. And we're also going to pass in the lexer state. We're going to pass in the lexer state in all of our methods in here. Now, before I continue with the lexer here, let's just play around a little bit on how we want our language to look like. I forgot to do that. I'm thinking we're going to go simple, and we're going to make a language that sort of looks like JavaScript. So let's just create an examples folder here outside of everything, and I'm going to create a file called hello. No, let's just call this main.hello. So, because our language is called hello at the moment, so our extension is going to be .hello. So let's just make a simple thing in here, and this is going to be our goal. Like this code that we write here, our goal is to make that code executable. So let's just do something simple. I'm thinking like var name is equal to John Doe, print name. So this is our own language. We can't run it right now, but our goal is to make this code runnable. It's a very simple goal. We're storing a variable. We're creating a variable with the contents John Doe, so the variable is a string, and we're printing it. Later, we will also add support for like multiplication and basic math stuff, basically. But this is our first goal, is to make this code executable. So let's continue with the lexer. We're also before we continue with the lexer, we're also going to have to define what a token is. So let's just do another file inside of the include folder called token.h. Let's just do if not define token age, define token age, and diff type def struct token struct token t, and the token is going to have two parameters. The first one is going to be an enum type, because we might have different types of tokens. So we might have a token. Let's look at our language here. What kind of tokens do we need to do this basic thing? We're going to need a token ID, and a token ID is basically an identifier for something. So it could be, this is going to be an ID, this is an ID, this is an ID, this is an ID. So we're going to need a token ID. We're also going to need a token equals. This is an equals token. And we're also going to need a token string. Now this entire thing here is a token string. Okay. We're also going to need a token semi for semicolon, and we're going to need a token lparen, token rparen. So we're going to have the left parentheses and the right parentheses. And I think that's it for now. And then we're also going to have a char value. Okay, so, and then we're going to need to define a token t init token so that we can create our token. And that function will have two parameters, int type and char value. Okay, so now we got a token struct that we can use in our lexer. So if we go into the lexer.h again, we can include token.age, and then we can do stuff with that. So I want to have a function called token t lexer get next token, lexer t lexer. So we'll call this function to get to the next token in the contents, basically. And most of our logic is actually going to be in this function. Okay, and we're also going to need a token t lexer collect string, lexer t lexer, and this function is basically going to define how to parse this string here. Okay. What else do we need? I think we'll start with that, and we'll see if I forgot something. I forgot something. I know what I forgot. We're also going to need a char lexer, or I mean a string. We're going to need a string lexer get current char as string lexer t lexer. Now this function is basically going to return this value here, but as a string, because this is a char, but we wanted to return a char array. Okay. So now we can go and copy these methods and create an implementation file for it. So we're going to create a lexer.c, and we're going to include /lexer.h. And let's define these methods here. Let's start by putting the bodies to the functions here. Okay, so let's start with the initialize, with the init method here. So we want to allocate memory for the struct. So lexer t lexer is equal to calloc 1 size of struct lexer struct. Then we want to do lexer contents is equal to contents, and lexer I is equal to 0, because we're going to start at the first character, and the lexer c, which is the current character, is going to be equal to contents I, or contents lexer I mean. Then we're going to return the lexer. Let's just see if this compiles. It does compile, but with some warnings. We need to include stdlib.h. I think that's it. There we go. It compiles without warnings. And every time I compile, it's when I type make here in the terminal. And if you want to recompile, you just do make clean. Okay. So now we can create our lexer here. Now we want to be able to advance. So now we're going to do, and remember this method is the method that is going to take us to the next character. So if lexer c not equals null character and lexer I is less than string, the length of our contents, lexer I plus equals 1 and we're gonna copy this line here. So now we have basically incremented our characters. Now we're at the next character. So I think that's it. Now I think if we compile this, we're gonna get a warning because we need to include string.age. And also I forgot to do Lexer contents. Now it compiles without warnings. Okay, so now we can use the Lexer advanced to go to the next character, basically. So, let's define our skip whitespace method. This method is just going to, if it encounters this whitespace here, it's just going to ignore it and go to the next character, basically. So, while Lexer C is equal to or 10. I'll show you why I put 10 in there in a moment. Lexer advance Lexer. So the 10 is actually the code for new line. So we want to skip new lines as well, basically. So that should be it. Now we want to, let's just see if we can compile. Yep. Now we're going to define the Lexer getNextToken method. So while Lexer C not equals null character. Oh, sorry, I forgot. This should not be an AND operation, or it should not be an OR operation. It should be an AND operation. No, it should be an OR operation. Sorry, I'm a bit tired. So while Lexer C not equals null character, and Lexer C and strlen, and Lexer I is less than strlen Lexer contents. So if we still have characters to parse, we're going to continue. So while Lexer C is not equals null character and Lexer I is less than the length of our content, while Lexer C is equal to, yeah, that's correct. Okay, so let's, the first thing we want to do here in our loop is to skip whitespace. So basically we're going to copy this line here. And we're going to do an if instead. So if we are encountering whitespace, then we're going to do Lexer skip whitespace. Let's just see if that compiles. Yes, it compiles. And now what we want to do is we want to, let's start with the basic character stuff. So let's switch Lexer C. So we're switching on the character and we're going to do case. So we got a couple tokens that we want to parse here. So for example, we have the equals, semi, and the parentheses. Case, let's start with equals. Then we're going to implement another method here actually. So let's do that first. So we need to do token T Lexer advance with token Lexer T Lexer token T token. And this is just a little helper method to make our code a bit cleaner. all it's going to do is do lexer advance lexer, and it's going to return our token. So case equals return lexer advance with token break, and we're going to pass in the lexer. We're going to need to make our window a bit bigger here. Pass in our lexer, and we're going to pass in init token lexer. Wait, what was the method? Type and value. So we're gonna create a token with the token equals type, and with the value lexer get current char as a string lexer. Now that is a bit, let's see if I can decrease my camera a bit. Okay, so let's just see if that compiles. Undefined reference to init token. Right, because we haven't defined our token yet. So let's just create another file in here called token touch token.c, and we're gonna include /token.h, and we're gonna do, we only have one method that we need to implement. It's this one, the init function. So we're gonna do token t token is equal to calloc1 size of struct token struct. Token type is equal to type. Token value is equal to value. Return token. Okay, so I think we should be able to compile now. Yes, but with some errors. We forgot to include stdlib.h. So now it compiles. Cool. So now we have the equal token working. We're gonna do the semi as well. Token semi. And we're gonna do the left parentheses. So token lparen. And we're gonna do the right parentheses. Token rparen. So I think that's the basic character things. So we got the equals, semi, lparen, rparen. Okay. Now these other ones, we're gonna have to do them a bit differently. Okay. So before we enter this switch statement, let's just compile again and see if that works. Yeah, it works. We're gonna do some other checks here. So we're gonna do if lexer c is equal to a quote, we're gonna parse a string, okay? Then we're gonna do return. No, we're gonna do token t token is equal to lexer collect string. Actually, I think we're just going to return this. Now we can probably put that in the switch as well, but let's just put it here for now. So now we have to write our collect string method. So what we're going to have to do is lexer advance lexer, because we're going to skip the quote that we're encountering. So let's skip that quote. And then we're going to do while lexer c not equals quote. So we're going to find the closing quote, if that makes sense. Or before we do that, we're going to have to allocate some memory for a string. So char value is equal to calloc1 size of char. And we're going to make that value 0 is equal to null character. And then we're just going to append characters to that value until we reaches the end quote. So char s is equal to, or string s is equal to lexer get current char s string lexer, and then we're gonna do value is equal to realloc value strlen value plus strlen s plus 1 times size of char. So we're reallocating the value here so that we can fit the string that we're creating here. So then we're going to do strucat value s. So we're basically appending the current character to this value here. Okay, so we found the closing quote. So we're going to ignore the closing quote by doing advance again. And then we're going to return a token string with the value. Let's compile. Compile without problems, cool. Now one problem is that we don't have the lexer get current char string, so let's define that. Char string is equal to calloc2 size of char. Str0 is equal to lexer c. Str1 is equal to null byte or null char. Return str. So can we compile? Yes, we can compile. Cool. So now there's one more thing that we haven't parsed, which is the token ID. So we're gonna add a function that I forgot to add before. So let's do lexer collect ID. So let's define that in the implementation file. Underneath the lexer collect string. Okay. Then we're gonna do sort of the same thing as we did in the collect string. So let's just copy the contents of this method into here. The only thing we're gonna change basically is this while loop here. So we're gonna do while is alnum. So while the current character is alphanumeric, we're gonna collect the value basically, and then we're gonna add a, I think that's correct. Then we're gonna do token ID instead. Let's see if it compiles. We don't have the alnum method. I wonder, I think that's like include type.h. I think, yeah, that was correct. Whoa, okay. So we're never calling the collect ID, so we need to do that as well. So let's do if lexer, if in our lexer get next token method, let's do if is alnum lexer c, return lexer collect ID lexer. Let's see if it compiles. Okay, I probably made some errors. Now we're gonna test our lexer, okay? So in our main method, we're gonna include slash lexer.h. Let's remove our print statement here. So now we're gonna create our lexer. So lexer t lexer is equal to init lexer. And we need to pass in some content here, okay? So let's just be a little bit hacky here and do, let's just copy this. And we're gonna do we'll implement a read file method later so that we can actually read that file, but for now we're just copying it into here. And then we're gonna do, we're gonna iterate through all the tokens. So let's define a token first. So token t token is equal to void. And then we're gonna do while token is equal to lexer get next token, lexer type not equals to, actually let's do not equals to void 0. Then we're gonna print token, let's print the, what was it, type value. So let's print the type and the value, token type, token value. So now we need to do one more thing. In our lexer.c, if we reach the end here, we're just going to return void, basically null. Okay, let's see if this compiles. It does compile. So now here comes the scary part. We're going to run our program. Let's do new line. Let's add a new line here as well. Okay. So actually, we're not going to be able to run our program, but we're going to be able to collect all the tokens from it, basically. So make clean, make. Let's run. And we're not getting anything. So why is this happening? While token. So I guess we're gonna have to do a little bit of debugging here. Let's see if we got stuck here. Oh, we need to include to be able to print. Okay, so we're not even entering here. Are we entering here? Yes, we're entering once. So something is weird. Do we come here? Yes, we do. Do we come here? No. So we're getting stuck in the collect ID function. Where is it? I'm thinking it might be this one actually. No. While is alnum printf. See. A. So we're getting stuck on an A character. Why are we getting stuck on an A character? Oh, I know why. We're not advancing. Okay, so Lexer advance Lexer. So the problem is that we're not advancing in here in the collect ID, and I noticed that we're not advancing in the collect string either. So we need to do that. So it kind of works. We got some errors. And one problem is that in our collect string, we should do, the value here should not be size of 1, it should be size of 2. No, it should be size of 1, sorry. And the problem is that we're advancing, we shouldn't advance here, and we shouldn't advance here. that was not the problem. So what is the problem? We're missing one character for some reason. And those are always, so the string is parsed correctly. It's the IDs that aren't parsed correctly. Oh, it's because we're advancing here. Sorry. There we go. We got all the... no, we don't have the left parent or the right parent for some reason. Why don't we have that? There we go. So here's the correct implementation. We should not advance after the while is elnum loop. So I remove that. We should not do that in the collect ID function. But in the collect string, we should do that because we're encountering an end quote and we don't want to parse that basically. So, cool. Our Lexer is basically done. And don't worry, if you weren't able to follow along, the source code will be in the description as well. So now if we do, let's make our terminal a little bit bigger. If we compile and we run the program, we got the var, we got the name, we got the equal sign, we got the string John Doe, we got the semi, we got the print, we got the left parenthesis, we got the name variable, and we got the right parentheses, and we got the semicolon. Cool. So our Lexer is currently done. Obviously, when we implement more functionality in the future, we're going to have to add a lot more stuff to the Lexer, such as plus signs, minus signs, and stuff like that. But yeah, now we're done with the Lexer. And as I said, I will put the source code in the description. And in the next part, we're going to start working on the parser, basically. And then after that, we're going to make the visitor so that we can actually run our code here. And it should print the name. So yeah, you've just written your first Lexer. This is a very important part of making a programming language. And as it looks like, it's our programming language is going to look sort of like JavaScript, I guess. So yeah, thank you for watching, and please like the video if you want to see more of this, so that I know that you're interested in watching this. And if you're not already a subscriber, please hit the subscribe button, and don't forget that the source code is in the description. And also the previous video will be in the description. So thank you so much for watching, and I'll see you in the next video.